A complex fraction is a fraction made up of fractions. It can be written like this, where you have one big fraction over another big fraction, or it can be like this, where I'm adding multiple fractions together over some other fractions. There are a couple ways you can tackle a problem like this. You can either say, let's find a common denominator in the numerator. So find a common denominator on top, which means I would need a 6 here. Whatever you put in the bottom, you also multiply in the top. And I'd need an x here. Whatever you put in the bottom, you also put in the top. Then my top part can be rewritten like that. Let's find a common denominator in the bottom. I need a 2 here. Whatever I multiply in the bottom, I have to also multiply in the top. And I need an x squared here. Also means I need to put it in the top. That means I can rewrite it like this. Okay, now I can keep the top fraction as is, change this fraction division bar sign to a multiplying, and flip the bottom fraction. So keep the top fraction as is, change division to multiplying, and flip this fraction. When we're simplifying, you need to factor and cancel if you have a fraction. So if I factor everything here, nothing factors actually, but I can cancel. Here my 2 over my 6 is going to be 1 over 3, and one of these x's will cancel with one of those. So I'm left with just an x and a 12 plus 5x in the top, and a 3 and an x squared plus 6 in the bottom. I moved my x to write it in the front because that's more of a standard notation, but you could have technically left it at the back. Okay, so that's one way, is find a common denominator in the top, finding a common denominator in the bottom, and now keep, change, flip. The other way is to multiply each of these 4 fractions by the least common denominator, or just multiply them one step at a time by each denominator. So this first denominator is an x, so if I multiply an x here, 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 I'm going to multiply it in the numerator. I'm going to multiply it in the top of each fraction. That means here my x's will cancel, and I'm left with just a 2. Nothing cancels in this second fraction. Nothing cancels in this third fraction. And technically 3x over x squared, the x and the squared cancel to be 3 over x. Okay, well that kind of helped, but not a lot. But I can do that same step again. Let's now multiply everything by a 6. So I can put times 6 in the numerator, or if there's not even a fraction, you just multiply by 6. Okay, so 2 times 6 is 12. Here my 6 and 6 cancels, or simplifies to 1 technically. 6 over 2 is 3. 3 times 6, 18. Okay, that was good. That got rid of 2 of our fractions. Can we do that one last time to get rid of this very last fraction? Yes, let's multiply everything by that x. The x's cancel, and I'm left with just an 18. You want to make sure you've simplified your complex fraction as much as possible, and to simplify fractions, we factor and cancel. So factor each part, the numerator and the denominator. In the top, all I can do is divide out an x. In the bottom, all I can do is divide out a 3. Oh, well, that didn't help us at all. Nothing cancels, so technically this can be your final answer, or this. Since nothing simplified, nothing canceled, I couldn't simplify further, so either answer is okay. And notice I got the same answer here as I got when I used the other method.